on that. Before that, my name is Ahmed. I'm a product manager on the Azure Kubernetes service team. I mainly focus on the AKS automatic kind of cluster and also the overall developer experience on AKS and how to improve it. So just a couple of logistics as we're starting. If you haven't been here yesterday, so the Wi-Fi, if you need to get access to the Wi-Fi, is on screen. And once you connect and open a browser, you should be able to log in with an attendee code. The restrooms are out there to my right, and we'll be having breaks and lunch today as well. So just briefly, times are a bit shifted, but we'll manage to get things done. So on the developer track, we're starting with topics around how to increase developer productivity and talking about our developer tools. Then we'll talk about how to build applications that use AI and how to build applications on top of AKS that use AI. We're going to cover an important topic, which is how to run stateful workloads on top of your Kubernetes clusters on Azure and best practices around that. And then we'll have a break. And then after the break, we'll come back to talk about securing workloads that run on AKS from a developer perspective and how to build resilient applications, resilient to failures, resilient to upgrades and so forth. And finally, before lunch, we're also going to be talking about an important topic, which is how to optimize your applications for cost effectiveness and how to manage scaling that comes as part of that. And then after the lunch, we'll switch to the operator track, where we'll talk about how to reduce complexity during cluster upgrades and what are the best practices that you can do there. We'll talk about security best practices from a cluster perspective, and then a full session on networking on top of AKS and how to set up the different networking options, and as well as end-to-end observability and troubleshooting from the cluster level, application level, as well as the networking layer as well. We'll have a session on resiliency, backup, and reliability. And then at the end of the day, we'll have an Ask the Expert session where we have a bunch of product managers in there. If you can stand up maybe or just raise your hands. So you have a number of PMs from the AKS team and from the Azure team that will be here to answer all of your questions. Does that sound good? Just to understand, how many of you are registered for both the dev track and the operator track that comes after that? So maybe about half of the room, okay? So there are a number of capabilities that we're building in AKS to help you build capable and modern applications. And it starts with creating a fully managed experience on the cluster level. And that includes things like management of nodes, of course, the cluster, but also components and system components that run on the cluster themselves, be it DNS, being the add-ons. We want to provide a fully managed experience so that you really focus on what you want to do the most, which is develop the applications. And speaking of developers, as we're building capabilities into AKS, we want to make sure that we want to provide you with the best productive development experience. So using the tools that you like to develop and integrating with popular CI/CD platforms, from GitHub Actions to Azure DevOps and others out there. And as part of that, providing a reliable platform to really host your mission-critical applications. So that could be applications that you're running or applications that you're running on behalf of your customers, or even for Microsoft, and we run internally a lot of applications on top of AKS, from Teams to Office to Xbox. And as part of that, how can you create your applications with scaling, and how can you scale across different regions and across the globe while managing your costs? And how can you manage patches and observability that have to come with that, and whether that's building on an observability platform that you bring in, or building on an integrated platform like Azure Monitor that monitors the entire stack from your infrastructure all the way to the application. And how can you talk about security and secure your applications across all of its layers? Providing a platform that is resilient and self-healing, and including tools to help you test that. And finally, we're doing all of this in the open source. So as one of the pillars that we do here, we like to do things in the open source so that you can run them on Azure, but also outside of Azure. And the other way around, like if you're running something outside of AKS and you want to host it on AKS, it should run. So obviously these are a lot of topics, and there's no way that we'll be able to cover all of this today. This will need a lot of time. So the good thing is that we've covered some of this content in KubeCon North America a couple of weeks ago, and at Microsoft Ignite. So you should be able to see recordings of these sessions on the Microsoft Azure YouTube, the AKS community channel on YouTube. And speaking of that, we also want to ask you, like, what content would you like to see on this community channel? So if you want to scan the QR code on the right here, it's a survey. You can tell us what you want to hear, and we'll see if we can create content for that. So now if you focus on what does it take to develop and deploy applications on Kubernetes, as a developer, you find that there's a lot of touch points that you have to go through, whether that's like how you build and deploy your application, how to apply security best practices really at the very early beginning stages of your development, so shifting security left, how to ensure that the app is resilient, and how to observe and troubleshoot things that come up with your application so that you can figure out what's going wrong or where you need to scale. And also how to apply these cost optimizations. So there's a lot of things here, and in today's session we'll touch upon how Azure or how AKS is helping you follow through these different application lifecycle touch points through the different capabilities. So the first session will be around developer tooling and the tools that we have to help you get started quickly with Azure and with AKS. And I'd like to start by where the developers start, which is the IDE. So in Visual Studio Code, we've created an extension called the AKS Kubernetes AKS extension for VS Code. And within Visual Studio Code, the AKS extension really helps you streamline the way you do things with your Kubernetes cluster. So you can connect to your Kubernetes clusters running on Azure. It has access, you can authenticate your Azure subscription to it. And then you can do some operations on your clusters right from within the Visual Studio Code experience. So you can deploy applications, you can generate or run Kubernetes commands, you can troubleshoot different things that are happening or viewing logs directly from within Visual Studio Code. And you can also set up like CI/CD pipelines. So the nice thing that I like about that is that I don't have to leave the IDE. I don't have to context switch and like go and use another tool or go log into the portal, do something. Everything is within my environment where I'm doing my code, and I can quickly do other operations on the cluster that can help me accomplish the task that I want. And at GitHub Universe, also like a couple of weeks ago, we announced the AKS plugin for the GitHub Copilot for Azure. So GitHub Copilot for Azure, the AKS extension there, it really gives you a chat interface within GitHub Copilot Chat in Visual Studio Code that helps you accomplish a lot of tasks that you might need to do, like creating clusters, creating kubectl commands, creating YAML files, and more. So I have a short demo to show how this looks like. So from Visual Studio Code, on the left here, there's a chat interface where you can ask things like, can you help me create an AKS cluster? And Visual Studio Code is connected to your Azure subscription. So I'll be able to select the Azure subscription that I want to use. And from within Visual Studio Code, I can create a dev test cluster for AKS. I can create an automatic cluster, all without having to go to the portal or run commands. It's executing directly against my Azure subscription that's configured. And in a few minutes, the cluster will get deployed, and then I can proceed with deploying the applications on top of it. So I can also view the progress of the deployment as it's happening, directly linked to the Azure portal. So as the deployment is going through, I should be able to use that cluster now from within the Visual Studio Code environment. So another thing that you can do here is deploy Kubernetes manifests that might be already on your file system. So in this example, I'm asking the extension to deploy a Kubernetes manifest. And once I go through that wizard, I'll be able to select the YAML file that I want to deploy and connect to the cluster that I just created. And from within Visual Studio Code as well, the application that I'm working on will be deployed to the cluster. And I find this really useful, especially during like dev test early stages of the application development, where I just want to get things started and I want to see output quickly without having to jump between a bunch of different tools. And finally, the last thing I'd like to show here is how you can also use the same experience to run Kubernetes commands. And especially if you're still getting started with Kubernetes, you might not know all of the commands. And even if you know them, there are certain commands that I just forget. Like, how can I apply a filter, for example, to filter a certain list of deployments for me? So you can run those commands right from within the Visual Studio Code interface as well, which I personally find a lot very useful to be able to just get things done quickly. Now, the other thing, what we've seen is the GitHub Copilot for Azure. The other thing is the Microsoft Copilot for Azure, which integrates within the Azure portal and also through the Azure CLI. And it really gives you, it has context of what you're running in your environment, so it knows the clusters that you're running, it knows the log analytics workspaces that you have. It can help you generate queries for logs. It can help you create new environments as well. So the first thing I want to show here is the new Azure AI shell, where you can, using natural language, ask things like create an AKS cluster and deploy an app in a specific namespace from this file. So after thinking for a while, it will generate a set of commands, CLI commands that can accomplish what you've asked. And the thing I really like about that as well is the parameter replacement. So you can replace parameters in the code that it generated. And then with another command, which is copy, which I'll do right now, I can copy the output of this command into my actual shell on the left there and actually run them. So we have like 4 commands now to create a cluster, to get the credentials of the cluster, to create a namespace, and deploy a YAML file. All within a few minutes. I'm able to do that without having to go and read documentation or like dig for the actual commands that I need to use, because the AI shell is trained and is fine-tuned on the documentation of Azure. So it should be able to generate accurate commands for doing so. And the same thing is in the portal. So if you go to the Azure portal, you can use the Azure Copilot to generate commands for simple things as like getting namespaces, but also like more involved things like show deployments from within, showing a deployment from a number of deployments from within a namespace. You can, for example, ask it to scale a deployment within a namespace. So for example, I'm asking a scale the deployments in my namespace to 5 replicas. And if I'm not trusting the output right away, I can actually dry run that so that it doesn't really execute the scaling or the command on the cluster right away. It just says, okay, this looks good to me. So I can then run that and actually get this running. Now this is a fairly basic command. So let's do something that's maybe a bit more involved, which is like show me all deployments in the store namespace with more than 3 replicas. This is something I always struggle with which is coming up with the like JSON path filter command here on the right. I always struggle with getting the byte command in there to help me. And this is one of the things I love about like using the Copilot or using Copilot to help me get things done. Last thing I want to show about Copilot as well is the integration in the portal to generate YAML files. So I can give it instructions to, for example, I want to create a deployment for this image to be deployed on Windows Node and have a specific like security context to use. And because this is also trained on the documentation of Kubernetes and on Azure, it can generate things like that easily without you having to go and figure out all of these things by yourself. Now, I'm not saying that you don't ever need to learn YAML, but this can help you really get beyond the initial phases of, I don't know where to start or I don't know what command to use exactly. It can help you accomplish this, this task. And finally, you can also ask it to explain things that are already running in your cluster. So you can go view any of the Kubernetes objects that are in your cluster already, and you can ask the Copilot to explain what's going on. So it can understand what the Kubernetes resource is trying to do, and provide it in like a human readable form to help you get started. So you've seen how to use AI to help you get started with your application development. And now I want to invite Sachi on stage to talk us through how to use AI in your applications, how to build applications that use AI as part of implementation. Sachi, over to you.
Thanks, Ahmed. Hi, everyone. Thanks for joining the developer track this morning. So I'll be talking about building intelligent apps on AKS and how AKS offers a strong foundation for your DevOps pipelines to start off with, and then integrating intelligence into your apps afterwards. So we're going to start off with automated deployments and draft. And as I mentioned before, diving into AI integration, it's key to have a strong foundation in your app deployment pipelines on AKS, which can seem a bit intimidating to start off with. So to ease this experience for app developers, we've introduced automated deployments, which leverages the open source project called Draft. And this simplifies the process of building and deploying your app pipelines on AKS. It can connect to GitHub repositories that house just your application code to start off with, and then create the Kubernetes manifest and the Docker file for then deploying onto AKS, versioning, and then integrating that into your pipelines afterwards. So, and as part of AKS Automatic, how many of you folks have heard about AKS Automatic, released in preview earlier this year? Great. So AKS Automatic actually leverages a lot of our GA and preview features that are best practices, offer safeguards within AKS, and kind of packages it together. So leveraging automated deployments as well, AKS Automatic is a new mode of operation. It's essentially a new SKU, starting off on AKS, where clusters are configured according to best practices to ensure application availability and resiliency. They run with dynamic code management, auto upgrades, best security practices, monitoring, and different policies to make sure that you start off in a secure environment and can avoid having to figure out all the knobs to tweak early on. So I'll dive into a demo of how automated deployments is integrated into AKS Automatic today. So as you start with Kubernetes, you might want a way to quickly prototype with your applications. And you might just be starting off with your application code only. So if it's in a GitHub repository, then you can just come straight to the Azure portal and choose to deploy an AKS automatic cluster, but first starting from the view of deploying your application. So you just have to do a little bit of the basic Azure setup, and then the steps here for setting up your application, then your cluster, and reviewing it. And you're connecting it to your GitHub repository with the application code. And when the Docker file is being configured, it can actually detect what language your application is written in. Then you would connect it to then in ACR in your private container registry, where the container file will then be stored and then pulled from later on. So we have different deployment options here, and we've introduced these improvements over the course of preview of AKS Automatic. So you have a choice in creating an automatic cluster initially or leveraging your existing AKS cluster. You would just input some of the details for your cluster, defining like the namespace, and we have a lot of the best practices integrated by default. So when it comes to monitoring, that was briefly showed. So you'd have managed Prometheus, managed Grafana for your observability tooling, and then log analytics as well. So you can kind of track the progress of your deployment. And what we do in AKS Automatic is we don't just go ahead and do the deployment just by default. We create a PR against that repository, and then you can go in and view the created Docker file, Kubernetes manifests, maybe add in some tweaks here and there if you do have some more experience with Kubernetes, or you can go ahead and just merge the PR. And this really integrates GitHub Actions as a part of your GitOps pipelines as a whole. And just within a few minutes, you can see that your application has been deployed onto AKS. So now from here, now you have a strong foundation for your application. How might you start into making it an intelligent app? So today, Azure offers a range of SaaS and PaaS options. Some of these are Azure OpenAI, Model Catalog, AML, which actually, by a show of hands, how many of you folks are using this like with your customers, or are they experimenting with these PaaS services? Okay, good to know. Yeah, these are a great way to start off with AI on Azure, when you have simple model discovery, easy AI integration, and then serving models specifically with non-sensitive data. We see at times that organizations might have more data residency, data governance regulations that you might need to expand past these out-of-box solutions. And that's where AKS has been making some developments in open source projects and then creating managed experience for those on Azure. So extending beyond this out-of-box solution, your app may require scaling out. For cost-effective infrastructure, you might need some fine-grained control on the underlying GPUs or even CPUs that are being allocated for your workloads. And those can also differ in what kind of AI workload you're running, whether it's inferencing, just serving a model, or fine-tuning, even RAG. And you might just want to be running your models locally for, as I mentioned, the security purposes and having more observability on those AI workloads. So this is where Kubernetes can be the platform to land your AI apps. There are many open source large language models readily available out there, and even more being developed that have the MIT Apache 2 license. And Hugging Face and Accelerator libraries are mature and offer a range of different techniques to optimize and improve the efficiency of your AI workloads. Different OSS frameworks, different serving engines like VLLM are out there and help improve those specific types of serving workloads. And Kubernetes is a natural platform choice to then bring together all of those open source tooling and integrate for scalability, performance, and security of your AI apps. But this might not be so easy. in getting started. There are some things that we've identified that may seem as potential challenges. So how would we ensure data security and sovereignty? Kubernetes itself can be a bit intimidating, and then how do we reduce the spend on GPUs? We know that all these GPUs that are being released, they may be more complex, but with that, sometimes costs are introduced. And we want to make sure to use them to their best extent without causing GPU out-of-memory errors, just optimizing the performance of GPUs for AI workloads. So that is where the Kubernetes AI toolchain operator comes in. How many of you folks have heard about this project on AKS? Okay, so I'll just go into the basics of how it works. Kaido was developed in open source by folks in the AKS team, and we also have a managed add-on that's in preview currently. And what it does is it really simplifies onboarding open source large language models onto AKS, and there are plenty of different use cases for your AI apps, whether it comes to creating recommendation engines, chatbots, et cetera, that are taking natural language and then summarizing, really optimizing the user experience as well as how they can be used internally to change internal processes for your applications. So Kaido, we recently released a developer experience in VS Code. You may have noticed that option previously that Ahmed showed in the developer experience in VS Code, and I'll go into a demo of how it works. You would choose a supported model within the Kaido repository and deploy it for inferencing on AKS just within minutes, all within the same IDE. So for an application developer, that may be a more simplified experience. For some open source updates on the project, we optimize GPU memory management by default. So Kaido enables certain optimizations from the hardware level, enabling cache clearing and expandable segments to help reduce out-of-memory errors. I won't go too much into the technicalities of that, but essentially trying to or helping avoid workload disruptions when you're running long-running AI workloads, whether it's model serving, fine-tuning, et cetera. And in open source, we recently released the integration with VLLM. I'll show how that works and how it's boosted the speed and performance of model serving by leveraging the open source VLLM serving engine. So Kaido is actually now a CNCF sandbox project, meaning it's showed its relevance within the AI space and consistently introducing optimizations to make running AI on Kubernetes easier. But what does this actually look like? I'll go into that now. So with the Kaido developer experience in VS Code, there are a range of different small language models and large language models supported today by Kaido. We allow you to start experimenting with a large language model in minutes and leveraging the GPU compute recommended by AKS for the model that you've chosen. You can then test and adjust the inference parameters in the model playground right within VS Code. So really enabling you to browse, deploy, and get started with AI quickly and simplify it within the developer experience. So starting off from the AKS extension here, you can choose to deploy a large language model with Kaido, and you would start by installing the operator onto your AKS cluster. And this is essentially the basic architecture of how the project works. It's leveraging, as well, other open source projects within the Kubernetes community. If you've heard of Carpenter, that will take care of the node provisioning for your workload, and then we define all the optimizations that are made from the model architecture for that GPU that's chosen. So now Kaido has been installed on the AKS cluster, and you can browse through our supported models. We're continuing to expand. We've started off with a strong set of foundation models, and from there, you can deploy the default workspace CRD. So this CRD essentially defines what are the resources that are needed for this specific model and the size of the model, because we don't want to be deploying too large of a GPU that's can be pretty complex and expensive, that's not really needed and may incur higher costs. We do that selection and optimization on your behalf. So you can track the progress of the deployment of your inferencing workload, and you can see the progress in VS Code itself and start testing with it. You can adjust the different configurable parameters for the model, and then get an output just within a few seconds, and then test out, let's say with temperature, you want to increase the creativity in the response. You can kind of toggle that back and forth, and then receive a different response from the model right there. So evaluating the performance, from there it might not match the context, or you might want to make it more context aware, and you can do so also with Kaido with Kaido fine-tuning that's supported. It's not yet in the VS Code experience, but it's also within our roadmap. So let's say that for your AI workload deployment, you want to look into the logs. If there's any issues that have happened along the way, you can track the pod deployment status, and then delete your workspace that has housed all of the resources that have been deployed as part of this workload, so that you don't have any idle costs that are kind of incurring on your cluster, and that's all shown here in VS Code. So another update that we have for Kaido is speeding up model serving with VLLM. I was talking to a few folks yesterday about what kind of optimizations that are made for model serving, and once you have a foundation model, you want it to be able to process incoming requests very quickly and match the performance of your application and your usage for your apps for the end user. So by integrating VLLM by default in version 4, the recent release of Kaido, it significantly improves the responsiveness and performance of your AI apps. Kaido also dynamically adjusts the max context length with the recommended GPU size, again, to reduce the frequency of different GPU failures and reduce the frequency of workload interruptions. And what VLLM introduces is an increase in model serving throughput over 15-fold as the number of concurrent requests grows. VLLM also expands support for the OpenAI APIs. So if you want to leverage the chat, completions, all of those different APIs, you can do so easily within Kaido itself. And I'll show kind of some experimentation that we've done internally, what that increase in throughput looks like. So for each of these levels of concurrency, we show on the left using the Hugging Face Transformers serving engine, and then the optimizations that VLLM does to batch incoming requests. And you can see the drastic increase in performance as the concurrency level increases. So we maintain the consistency running on a single GPU node with the same data set and same model. And you can see the serving throughput for the Phi 3 model very much improved with VLLM. So how would I switch from the default Hugging Face Transformers today in Kaido as the serving runtime to VLLM? Well, version 4 actually makes the VLLM by default. So this is what the CRD might look like. Just within a few lines of YAML code, you have everything defined for your inferencing workload deployment, for example, for the Falcon 7B model. And within the annotations, the new field here is for your model runtime. So by default, it'll be VLLM, but if you'd like to switch back to transformers, you can also do so in updating that CRD. And as I mentioned, so for leveraging the OpenAI different APIs, how would you do that? Just within 3 steps. So you would, for your model of choice, for example, the Phi 3.5 model for inferencing, you would apply the CRD, then get the cluster IP for your deployment. And then as you're interacting with the model, you can just leverage whichever OpenAI API that you would want. So you could either do chat, this one is V1 completions, and then see the difference in that model interaction right there. So in order to support AI workloads in general from a more foundational level, we also are expanding support for different GPUs, using it for different contexts. So let's say that you're mainly running on Windows OS. Now in public preview, we have new driver type selection for Windows GPU. So NVIDIA has two different drivers for their GPUs, Grid and CUDA, that are leveraged for different types of workloads. And you have the choice in choosing between these different driver types. So you can visit this link just to try that out in public preview. And driver type selection is specifically supported for Windows GPU and not for Linux GPU-enabled node pools. So this demo just demonstrates how you would be able to do so. You'd be creating your resource group and then leveraging this as a AKS preview feature. You'd just be getting that Windows GPU node up and running. We want to make sure to have a few things set when we're enabling that GPU node pool. So defining the OS type as Windows specifically, and then using a supported VM size for GPU workloads. So after the node pool is created, you can verify that the GPU has been allocated by describing node. And at the bottom of the described node, you'll see that the DirectX plugin has been used. And running our GPU workload, we can see that it has been successfully deployed. So looking at our AKS roadmap for intelligent apps, what are we working towards, and what do we want to continue to do to increase the performance of AI on AKS? When it comes to scheduling AI workloads, depending on the workload type, for example, when it comes to incoming requests, you can process them in parallel. And making sure that that can happen on AKS boils down to how the scheduler schedules those workloads, so that you can do batch processing, not just for AI workloads, but also for all different sorts of batch workloads that don't have dependencies on each other. So what we're working on supporting soon in public preview is enabling co-scheduling to run AI and batch workloads to completion without user intervention, as well as some cost optimizations for node bin packing. So if you see that at times you have idle nodes, specifically idle GPU nodes that are not being used to their fullest extent, you would be able to enable node bin packing for higher utilization of those resources, and essentially preferring the nodes that might not be more on the empty side for the scheduler to then place workloads onto those nodes. And we would allow for flexible configuration, enabling and disabling these scheduling plugins, or reverting back to default scheduling mechanisms in case it's affecting your app in any certain way, and then pre-validated scheduler profiles that are essentially YAML manifests that you can just apply directly onto your AKS cluster to change the scheduling mechanism. So that will be coming soon in the new year, as well as supporting RAG in Kaido. So how many of you folks know what RAG is? Okay, can you tell me what RAG is, or like how it's used, different use cases? Yes. Sorry, not to put you on the spot there.
It's just generating the data based on, it's generating the data based on whatever data which we have stored in our files or PDFs, and based on that we can tune the prompt and write a program to get the information based on those data.
Yes, yeah, That's a great way to explain it. So taking the information that you already have, and that might be stored in documents or large text files, and being able to retrieve that more efficiently with a certain type of model that you want. So in comparison to fine-tuning, what fine-tuning does is change the model, the layers of the model itself. But if you don't necessarily need to do that, you just need to have your model stay up to date with new data flowing into your application, you would be able to leverage RAG for that. So querying, storing the data, and so forth, that is what Kaido would be looking to integrate soon in the open source project. So retrieving the most relevant information and keeping that kind of feedback loop up to date, organizing the questions that are asked by the end user, and retrieving information into prompts, breaking the docs into chunks and indexing them into a vector store using an embedding API. So this would be leveraging different types of file storage and remaining pluggable so that whatever you have today, you can bring that to Kaido and integrate it for RAG. So that's what we're looking to have in our roadmap for Kaido, and have a range of different AI workloads that are supported and able to be integrated into your intelligent applications. If you folks are joining the KubeCon India tomorrow, I'll be doing a demo session of end-to-end AI pipelines leveraging Kaido and a range of different open source tooling that you can essentially just apply directly onto your cluster and then plug in different monitoring tools, CI/CD, and so forth for an automated end-to-end AI retraining workflow. Yeah, so speaking of data storage, I'm going to pass it over to Shekhar. We'll be talking about stateful applications on AKS. Thank you.
Hey, good morning, everyone. So I'm Shekhar. I apologize in advance because I have a sore throat. So if I start sounding like Batman, please don't be scared. It's still me. So we've seen how to deploy applications that use AI models. So now we are going to do a little bit of a boring subject, which is storage. It's not boring. I'm not going to make it boring. Okay. So we are seeing more and more adoption of the Kubernetes framework. So we are seeing applications that are being migrated from on-prem to cloud. Kubernetes originally was designed for stateless. It has grown, and now we are running stateful applications on them. And with stateful applications, well, it comes with its own set of challenges. So we are just quickly going to go over what challenges we are currently facing, what you are currently facing. We'll discuss about the options that are available to address those challenges. We'll start with block storage. Okay, is this audible? Sorry, this is visible, right? Yeah. Shared file storages. The second option. I'm going to walk you through the roadmap that we have for features, exciting features that are coming up within the next 12 months. And finally, key takeaways. So how many of you are running stateful workloads in Azure? Okay. Well, in Kubernetes, we got stateless workload and we have stateful workloads. Okay, stateless workloads are more or less simple. Okay, they come up, they do their work, and then basically, they're decommissioned. They have replica sets to address load balancing challenges, and you can have some additional properties like stickiness, which if you have attended the lab yesterday, right, we demoed that. With stateful workloads, your first challenge is that it needs to remember what it was doing, which means you need storage. With storage, the first thing that comes is cost. The second thing which comes with storage is a property called performance. If you want high performance, well, there is a cost. If you go for lower cost, well, you don't know how it's going to affect your performance, right? And with storage, there comes a third property, which I have not mentioned here, which is data. And data has gravity. Okay, and that gravity comes from the importance of that data to your business, which means now you need to have redundancy. You also need to protect that data. Okay, so now we have 4 pillars. We've got cost, we got performance, 2 which I have not mentioned here, which is redundancy and data protection. So we have a complete session around data protection after in the series. So for those folks who are deploying stateful applications, can I kind of like get an emotion? Like, how do you feel when you're deploying a stateful application? You can kind of like just go this, this, or this. Okay, yeah. So we are going to address those challenges in this session. We are going to make it very, very easy for you to deploy stateful application. Okay, so how many of these workloads you're currently running on-prem? On-prem. You can raise your hands. Okay. How many of these are you planning to migrate to Azure in the near future? Okay, so these are some of the workloads out of a very long list for which we have received feedback from you and the community. And these are currently being run on Kubernetes as stateful workloads. There are some workloads in here for which I'll share design patterns at the end of this session, which are specifically built to address the cost, performance, redundancy, and your data security challenges. Okay, so a quick primer on stateful and stateless workloads. So we've got stateful set and we got replica set, which are basically Kubernetes AI. Yeah, they're basically API objects. Replica, we'll start with replica sets because that's the most simplest one, even though the sequence is the other way around. So replica set is essentially for stateless workloads, right? And replica set basically says how many copies of that stateless workloads you're gonna run. So think of it like a front end, a web front end, which just basically serves users, okay? And it has a stateful store somewhere else to which it's connecting and retrieving the information. Replica sets are the most easiest ones, okay? And that was originally the intended workload when Kubernetes was like kind of born way back. And then we have stateful set. So stateful set is what or how you make your workload stateful. So when you enable stateful set, you introduce 2 properties. You introduce a network identity because a stateful workload needs to know who is connecting to it and who it has to respond to. Okay, and by extension, then it needs a persistent volume because it needs to remember who has connected to it for a service and who it is serving. Okay, now, if you take these 2 properties, the stateful application also has to be scalable, right? Then now we are bringing a little bit of complexity in here. We need sequencing. You cannot take a storage and a network identity of one instance and assign it to another. Or like assign a network identity to another instance and storage to another. So you need ordering, you need sequence, okay? Which is very important. And then lastly, if you're doing all of that, the whole purpose of you putting an application in Kubernetes is that continuous integration and continuous deployment. You make a change, it goes in. You make a change, it goes in, which means there has to be a graceful update. And it has to be done in the correct sequence. Okay, so stateful sets are definitely complex. I feel you. Okay, they're definitely complex. So now that we have understood the difference between stateful and stateless workloads, we are now going to address those 4 challenges: cost, performance, redundancy, and data protection. So within Azure, the storage options that we provide to you can be classified into 2 groups. We've got block storage and we've got share file storage. So block storage is optimized for read, write once. That is, a volume that you create is used by one instance of a workload only. Okay, think of it like a virtual machine. You have a disk. That disk is not being shared by any other virtual machine, right? We just kind of like condense it into a container. Now within block storage, you've got three options. We got the classic Azure disk. So within Azure disk, we have multiple options. We've got SKUs ranging from standard HDD all the way to ultra tier. So we give you a flexibility between cost and performance. Okay, we've got Elastic SAN, which you can provision either as LRS or ZRS. ZRS is self-healing, and it's more suitable if you really want enterprise scale. And we just released Elastic SAN, by the way. And then we have the local disk, which is what we are going to refer going forward as ephemeral disks, right? NVMe, very, very fast, like ludicrous fast. The ludicrous mode in the car. I'm not going to mention the car name, sorry, for copyright reasons. But they are volatile. And I'm gonna tell you how we actually make that volatile storage persistent going forward. And then we have the shared file storage. So if you have a requirement for read, write many, right? So we got Azure files, we got Azure NetApp files, and then we have an Azure Blob, which is basically our object storage offering. Now, when I say read, write many, it means you are allowing access to the volume from multiple points. Now, I'm emphasizing on the word volume, not file, because parallel access to a file is a different problem in itself. Okay. Now, in all of this, all these options, they address the 4 pillars that we have. So you got cost-effective options all the way to high-performance options. Within Azure Disk, we have zone redundant options, that is standard SSD ZRS, and we have premium SSD ZRS. So if you have a zone redundancy requirement, we've got you covered. You can provision the same in Elastic SAN. Azure Files has redundancy all the way from LRS to GRS. So standard file shares, you can get in even GRS options. So if your application requires it, we've got that covered. Finally, we at Microsoft take security very, very seriously. Okay, in fact, any solution that we are design or propose, security has to be the first one. So I'll give an example. If you're using Azure Disk and you're using Azure Disk CSI driver, you have an option to encrypt your disk with your own key. So we don't know what's happening inside your disk. We genuinely don't know what's happening inside there. Okay, and if you're using Azure Files and you're using the Azure File CSI driver, you can provision a private endpoint. Private endpoint means that your traffic is not going through the edge network. It will always remain within your virtual network. Okay, it cannot be, how do I say? It's basically to prevent man-in-the-middle attack. And if you're using SMB file share, we've got encryption in transit enabled by default. Okay, so even if somebody gets in there and places a virtual machine and starts sniffing in traffic, which is not going to happen in the first place, they don't know what you're transmitting. So how do you deploy all these in your AKS? Like I've given you 6 options. How do you deploy all these? So we have the classic CSI driver ecosystem that's available, and all of these options you can deploy using CSI driver. You can create persistent volumes out of these and attach to your workloads. We've got Azure CSI drivers for disk, Azure Files, Blob, and ephemeral disks. The Elastic SAN is a bit of an exception here because it relies on the Kubernetes iSCSI driver. Okay, it's not our driver yet, so we rely on the open source publicly contributed driver. For NetApp, we have the Astra Trident driver from NetApp that you can use. Okay, and so here lies the problem. You got 6 drivers. Actually, you got 7 drivers because there are 2 drivers for Azure Disk. Okay, so you got 7 drivers, all in all. And 2 of them are, well, basically outside the Azure ecosystem. So, in order to address that complexity, we've got Azure Container Storage. So I'm just going to refer Azure Container Storage as AC Store from now on. Just for my throat, sorry. So we just recently released the AC Store. It went in GA, and it's primarily for block storage. What it does is, first of all, if you want to provision any one of those three, Azure Disk, Elastic SAN, or you want to use the ephemeral disk for high throughput local storage, you now only have to work with one control plane, which is AC Store. And I have a code example. So you no longer have to deal with 3-4 CSI drivers, which increases your complexities, right? And let's face it, in an operational environment, or like less is better. Okay, so one of the concepts that we introduced in Azure Container Storage is creation of pools. Okay, and I'll explain this in architecture later. It's gonna be less boring. I'm sorry if this feels a bit boring. I'm gonna make it interesting in the next one, I promise. So the key benefit that you get with ACS is that we improve your storage utilization, thereby, it results in lower total cost of operation. It's a Kubernetes native volume orchestration, which means it's not something external that you have to deal with. It's part of the Kubernetes ecosystem. You don't have to deal with multiple planes, control planes. One of the key benefits that we observed was that if you are rapidly scaling out your workload, or if you are observing a lot of failovers, right, the detachment and reattachment of persistent volumes was found to be much, much faster in AC Store compared to CSI driver, which means your applications can scale faster. They can scale in faster as well. They can fail over faster, which means lower downtime. And finally, because you now only have to work with one driver, well, I'll say, at least for me, it makes my life easier. So over to the interesting part, which is the architecture. So how is it different from CSI driver? So the first thing that, when I use the term pool, okay, this is where things change. So today, when you're provisioning a persistent volume through CSI driver, you create a disk, or basically, essentially, it creates a disk, attaches it to the node pool, and then creates a persistent volume on it. And here lies the complication. Take an example of an AKS cluster. It has 40 nodes of size D2 DS V5. Okay, someone can just kind of like note it down for computation. I'm just gonna do a back of the paper napkin calculation here. 40 nodes in a node pool of size D2 DS V5. D2 DS V5 can accept a maximum of 4 data disks. So how many total data disks can be attached to the cluster? 160. Okay, how many total persistent volumes can you create in that cluster? 160. Okay, with ACS, AC Store, not ACS, ACS is a different product, I'm sorry. With AC Store, you can create a total of 3,000 persistent volumes in your cluster. Okay, now this was a very small example because D2 DS, you only have 2 cores. One core is reserved for the operating system, and the remaining 1 core is reserved for, you can use that for your container applications, which isn't much, but when you start scaling it up, when you start using bigger VMs for your node pool, right, that is where you start hitting a limit as to how many persistent volumes you can attach, which means now you're limited by how many stateful workloads that you can run, and you will run into a situation in production environment where you cannot share that node pool with anyone else. Okay, it can be financial, it can be security boundary, or it's running a workload which is gonna be in DMZ, which means you cannot have anyone else coming in and running something else on it. Which means all that compute capacity is something which you're not using. Compute is way more expensive than storage. Compute and memory is way more expensive than storage. So with this, you can run more workloads. You can optimize how many workloads you can run. Your node pools can be smaller. First, we address the first challenge, total cost of ownership, reduced. Okay. Second, because you're no longer limited by the number of disks that you're attaching, what essentially it does is it takes one disk, okay, and it creates a storage pool on top of it, which is basically just imagine if you're, how many of you work with VirtualBox or Hyper-V? Right, or any virtualization software. What do you do? When you create a VM, you create a virtual hard drive. Right, it's not a physical disk, it's a virtual hard drive. Now you're getting the relationship, right? The PVs are no longer linked to the disk. They are basically virtual images that are residing on that single disk, and we have created a pool out of it. Which means if you need to scale out, you no longer have to wait for Azure to create a disk and attach it to the VM, format it, create a PV on it, and then give it to your workload. Your PVs get created like this. You want to clone? Like this. You want to detach and retach? Like this. You want to scale out? You want to scale in? Like this. Okay, I did too many, sorry. Okay, so that's the big advantage here. The second, you see Azure Elastic-SAN here, right? So Elastic-SAN is an exception because it connects on iSCSI. So you'll say, well, I don't have to deal with disk limitations anymore. iSCSI, right? I can attach hundreds of them. Well, today, Elastic-SAN, the minimum volume size is 1 terabyte. We need to provision 1 terabyte to meet that performance requirement. What if you have a requirement of PV which is only 20 GB? Okay. If you're using a CSI driver, now you're stuck. With AC Store, now you can provision, let's say, 200 PVs of 50 gigabytes in size. So a lot more efficient, right? And lastly, we got the ephemeral disk. So ephemeral disk, I'll just quickly go over it. So we have NVMe storage. So when you create a node pool of, let's say, an L size queue, you get an ephemeral disk in there, which is NVMe. NVMe is volatile, which means once you restart it, the data in there is gone. But NVMe is super fast, like ultra fast. Because the data access that you do on NVMe bypasses everything. The CPU just goes and gets the data and gives it to you. And now you'll ask, hey, we are talking about stateful workloads. Why are you giving me a volatile storage? I mean, like my node goes out, my data goes out. Well, in AC Store, we got a cool new feature. When you create a node pool, I'll give an example. Let's say standard L8S SKU, which has NVMe option available in there. You attach an NVMe storage. With AC Store, you can create a replica. That means, let's say you have a node pool of 5 machines. The data in all the NVMe storage is replicated. Which means you have let's say you have a deployment here which is writing to that NVMe storage. You have other deployments here connected to the same NVMe storage. They can read the data. The I/O which is being done here is being replicated everywhere else. So if one node goes down, you still have the replicated pool. Another one comes up, it gets replicated. It is not a pure persistent storage because if you have a complete node pool outage, as in somebody goes and deletes the node pool while you lose the data, that shouldn't happen in the first place because you shouldn't go and delete a node pool when you have workloads running on it. But it gives you something which is between very, very high performance and very, very high resilience. Okay. It's not perfectly resilient, but you're getting the advantage of very high performance. That is what I wanted to say. I'm sorry. Yeah. No, so this is not currently available for a This is not currently available for a multi-region because it's still restricted to a single region. This is intended for zone redundancy.
Okay.
I have a lab.
Let's say Kafka.
Yeah. Sorry.
Like Kafka when we use, right? So in a multi region, that it should be like we use Kafka, Confluent Kafka, and the data it uses persistent volumes, right?
Correct.
Then we use multi-region in a way that the applications can put messages and the consumers can read it, right? So we have that model, multi-region model. So like you said, it's not yet in the multi-region model, right?
Yeah. So this is, but this, like I said, this is intended for workloads that require very, very high throughput and ultra sub-millisecond latency. Actually, I should have used the term ultra sub-millisecond latencies. If you want geo-redundant options like multi-region, we have, you can rely on Azure files with geo-redundant geo-redundant replication. And let's connect after this. I'll
Sure,
give you a
sure.
few more
Yeah,
options.
yeah, sure. Thank you.
So essentially, this is so these are the advantage of AZ Store. Okay, you optimize your storage usage. You lower your total cost of ownership by effectively utilizing the storage of your underlying disk, whether it is elastic SAN volume, as a pool, and you get to use NVMe as ultra fast local storage with added redundancy within a given region. So there was a slide I wanted to show you about how it can actually give you performance improvement as well as cost saving. So just give me a second. I'm going to try and see if we can get that slide. Oh, yeah, sorry. Okay. Right. So this is just a quick comparison table which I made, CSI versus AC Store. So the max, for example, 1 PV per disk, maximum of 64 per node if you use the highest performing VM SKU today. With AC Store, a maximum of 3,000 persistent volumes per cluster. And for example, I've just kind of like taken a rough calculation here. So, for example, you have a pod, it has a requirement of, there are 2 containers running on it. So you got 2 PVs in there. One has a need for 100 gigabyte of storage, peaking out at 3,000 IOPS and 125 megabyte per second. So I'm not saying it's 100% usage, it's more or less, it's gonna spike at that point somewhere down the line. Similarly, you have another requirement, 256 gigabyte with 5,000 IOPS and 200 megabyte per second. If you were using CSI and you were using premium SSD, you'd need to provision a 1 TB volume because you can get up to 5,000 IOPS in there and 200 megabyte per second throughput. Okay, now you have to use 2 terabyte disks. Now, if you were using AC Store and your workloads, now these are spike values, which means they're not 100% running at 5,000 IOPS all the time. You can see that we are now effectively partitioning this 1 TB and then we are able to provide this. The disk still has the IOPS required to address 3,000 IOPS and 200 megabyte per second. Actually, it should be 125, so I apologize. Like I said, this was a back of the paper napkin calculation. So it is still able to provide the required storage performance as and when it needs. And then you are cutting your total cost by half. Now, if your workload requirement increases, that is, you are seeing more and more spikes, higher spikes, you can go ahead and then increase the disk size. But in this example, it will basically give you a reduction in cost. There are some key differences between CSI and AC Store. So that needs to be kept in mind. So if you're using Windows workload, right, we recommend that you continue to use CSI drivers. And another important thing, so we have dynamic and static PVs. So if you are using a static persistent volume, that is, once the workload is gone, but the volume is still there, you want to reuse it again in a different deployment, that currently cannot be done with AC Store. So you have to rely on the Azure CSI driver. And this particular point is going to come in the next topic when we are going to start discussing about shared file storages. By the way, a very important thing. We are discussing about AZ Store, okay? We are discussing it for block storage. Does it mean you should stop using CSI driver? No. So AC Store is well built upon OpenEBS. Okay, and OpenEBS itself builds on top of a CSI driver ecosystem. So we are not replacing the CSI driver. Okay, in fact, we are dependent upon CSI drivers because any new features, they first go into the CSI driver respective, in our case, Azure CSI driver, and then they'll flow up to AZ Store. What we are doing with AC Store is we are bringing in operational efficiency, we are bringing in ways for you to optimize your total cost of ownership, and we are trying to make it easier for developers to quickly deploy volumes and then reclaim them. Okay, so today If you want to deploy AC store, and if you're deploying a new cluster, well, it's very easy. You can do that with the AZ CLI command. You can create a new cluster and directly specify which underlying storage that you want to use when you want to use AZ store. If you already have an existing cluster, use AZ AKS update command to enable that. This will take anywhere between 5 to 10 minutes, and it is non-disruptive, which means it's not going to take down your workloads. It's not going to cause you an outage. You can run it, go back, grab a coffee, come back, and it's done. One of the things that we really wanted to do was, whether you're using a CSI driver or whether you're using an AZ store, we wanted to make your experience consistent. And the way it works today is, the AKS operations in the real world is typically divided between operators and developers. So the operators will come in, they'll deploy the cluster, they'll deploy the configuration network, they'll create the storage classification. They may have some mandate to say that, hey, only use these storage accounts, only use this resource group to provision resources, etc. They'll do that, and they'll basically hand it over to the developers, who are then going to create persistent volume claims, attach it to the deployments, and then start running the workload. With AZ Store, you still follow the same process. The only difference is, so I've got a sample code here. It's a working code. I tested it myself yesterday. Instead of specifying, where did it go? Yeah, so you can see storage class name on line number 23. So instead of using something like manage CSI, you now point it to Azure AC Store Azure Disk. And then in line number 9, you simply specify what kind of storage you want. So you want premium LRS, premium V2 LRS, yeah. You want standard HDD, you want NVMe, you want Elastic SAN, that's it. Line number 23 always remains the same. So now that we have talked about CSI drivers and AZ Store, okay, we talked about block storage. Now we're going to talk about shared file storages. So shared file storages are used where you have a requirement for read, write, many. That means your single volume is being shared by 2 or more workloads, okay? And I'm emphasizing on the volume part, not the file part, because even in operating system world, even in the bare metal world, parallel access to a single file is a tricky object. We are not going to cover that here. That's a completely different subject. So we got 3 options for you: Azure files, Azure NetApp files, and if you have a requirement for object storage, very, very fast object storage, ridiculously fast object storage, you got Azure blobs. So Azure Files is an Azure managed file share. We offer SMB 3.11, 3.0, and NFS 4.1. It's 100% POSIX compliant, so if you're running Linux-based workload, it's perfect. Okay, it gives you redundancy options all the way from LRS, ZRS, and if you provision standard file shares, GRS. Okay. If you provision premium, which is kind of like required for NFS, at the moment we are limited to LRS and ZRS. We have recently released metadata caching for SMB. It's in preview. I'm going to talk about it later. It's a really cool feature, and I'll tell you how it improves performance by a considerable scale on your SMB if you're using SMB for your workloads. And then we have also introduced vaulted backup for SMB. We're going to cover that in a section after the break. I said break and I saw quite a bit of eyes light up. Okay. Yeah. And then we have an Azure NetApp Files. Azure NetApp Files is basically an Azure managed ONTAP. If you have a requirement for sub-millisecond latency, like you're running databases. Okay, this is an option for you. It has an option. So it offers NFS 3.0, NFS 4.1, and SMB, and you can export volumes with dual protocol, which means your workloads are accessing this on NFS. You are accessing the share outside on SMB. This is an actual scenario where I just shared. I have implemented this in one environment where a share is being used by one set of workloads, and the same share data is being put in there by another workload. Even users, they're just kind of mounting the share and putting data in there, and it is being consumed by your workloads within AKS. So that's just one of the examples which I gave like how it can be done. And the third is Azure Blob. So Azure Blob is our object storage. It gives you very, very fast read and put for large file objects. In addition to this, if you have a requirement for lifecycle management, like if you're storing backups and you say, I move these files into an archive after X amount of time, which is a lower tier storage, you can do that in Azure Blob. Today we allow Azure Blob export through NFS 3.0, FTP, SFTP, and Hadoop file system through the ADLS Gen 2 driver. If you want to use ADLS Gen 2 driver within your Kubernetes workload, there's no CSI driver for it. You basically have to make sure that your container contains the driver. It has outbound access to the blob storage. Using that, you can use an HNS-enabled blob storage for your computation. We also have BlobFuse 2, by the way, and BlobFuse 2 is how we provide blob access to your container. So BlobFuse 2 is a driver which you install on Linux, and it exposes the blob storage as a native Linux file system. For all intent and purposes, it's a mount point. You put data in there, you read data from there. That's it. You don't have to deal with all the complexities of making REST calls to fetch the files. It makes, if you have an application, if you're bringing in a legacy application which works primarily on file system, use BlobFuse 2. Okay, so we talked about metadata caching. So what is metadata caching? Or what is metadata operations? So essentially, any operation that involves opening a file, reading a file, creating a file, deleting a file is metadata operation. Everything else that you do is basically data operation, that you write data onto the underlying storage. For example, WordPress. It's a very simple application, but it is metadata heavy because it is reading a lot of files, it's opening a lot of files. So metadata caching is something that we have recently introduced for SMB shares and for REST operations. By the way, you need to use premium file share in order to utilize this, and it's currently in preview in limited region. So we have observed up to overall a 50% improvement in performance when this feature is enabled, which includes access time, latency, and overall throughput. So this is an example. We have a demo for this. Unfortunately, it's a 35 minutes demo, which is longer than this session was scheduled for. So I request everyone to go to this particular link. So we have a demo here, which uses GitHub CI/CD. And GitHub CI/CD, when it is reading a lot of files, it's a metadata heavy operation. Okay, so we got a demo, recorded demo over here. It's a YouTube link. If you go into the video description, there is also a link to the GitHub repo where the code is kept. I would really like you all to, give it a try, download the code, and if possible, run it on your, Azure subscription, so that you can actually get a feel of the kind of performance improvement that you're getting through this particular feature. So let's head to the storage roadmap for AKS. Now, before we go here, just want to make something clear. We make a lot of changes, we make a lot of improvements in storage. So we cannot cover all of them. What we are going to do here is we'll cover the most significant ones for AKS. And the roadmaps which I'm going to share with you are laid out over the period of next 12 months. There's no fixed date for it. It's coming, but it's spanned over the next 12 months. So recent updates, Azure Container Storage for Azure Disk and Ephemeral Disk went GA in 2024. We have within Azure CSI Disk live resize for premium SSD V2 and Ultra Disk, which means you can increase the underlying disk size without having to take your workload offline. For NFS, snapshots and soft delete. This is for Azure files. And we just recently released Provision v2 model. So in Provision v2 model for Azure Files standard, previously when you were provisioning a share, you would provision, let's say 100 terabytes, 100 TB share. The performance and the IOPS that you get from it is based on the size of the volume that you're provisioning. With Provision v2, currently in standard share, you provision volume separately, you provision IOPS separately, you provision throughput separately. So you are exactly paying for what you have requested. It's a lot more efficient, and it is done at a Fabric side. Within NetApp, we have introduced cross-zone replication. So if you would like to have zone redundancy and you're using a NetApp volume, you can configure cross-zone replication to another NetApp account that you have created. And we have reduced the minimum capacity size from 2 terabyte to 1 terabyte. And lastly, BlockFuse 2, we have various client-side improvements that we have. So if you're using BlockFuse, by the way, we actually recorded 10 plus terabyte throughput using BlockFuse 2. 10 Tbps throughput. So now you're getting a picture of what kind of operations you can run, what kind of on BlockFuse, right? What's coming? AC store integration with the ephemeral disk, Elastic-SAN is currently in preview. We want to take it to GA, so that's coming. We have Performance Plus for premium SSD, standard SSD, and standard HDD. It's currently in preview. It's coming. Metadata caching, we just discussed. We want to take it to GA. Premium file shares, it's currently in preview. You can request it in selected regions. Minimum file share size reduced from 100 GB to 32 GB. So even more efficient utilization of the shares that you're provisioning. Today, we have for SMB shares, we have encryption in transit. We are bringing it to NFS. Again, I'm emphasizing our focus on security. NetApp, minimum volume size reduced from 100 GB to 50 GB. It's in preview, selected regions. We want to bring it to GA. And finally, BlockFuse 2. So if you're running AI/ML workloads, we are working to see how we can preload your data onto the nodes so that you don't have to wait for data to come in from Azure storage account to your local storage and then you start accessing it. Yeah, so this is a cool new feature. Ahmed shared it a while back. I'm just re-emphasizing it here. So when you're using AKS and when you have to when you're working with AKS through the portal, and if you're like me, who's a bit challenged with code and documentation, so we now have Copilot integrated in there. You can just simply go and say, please create a template for me that does this task, and it will create a template for you. Or if you have an existing code, you can kind of just paste it in the editor, in the AKS, create with YAML option, and you can say, can you kind of modify it that I want to use, let's say, AC store driver. It'll edit it for you, and then you can do a dry run from here before you do a deployment. So you know that your code is correct. Just wanted to share something cool. So key takeaways. Stateful workloads are here to stay. Okay, which means, and they come with their own challenges. We need to make sure that those challenges are addressed. And we have done that through various storage offerings in Azure. So we have block storage where for your read and write once. And we have also introduced AZ Store, through which you can simplify how you use block storage in your environment. And if you have a requirement for read, write many, well, we have a multitude of options with Azure shared file options. You have Azure Files. If you have performance requirement, you can go with Azure NetApp Files. And if you have a requirement for very high speed object storage, we have Azure Blob Storage for that. So a while back, I mentioned that we have few applications that, if you remember the application slide at the starting, and I mentioned that we have some applications for which we have published some patterns. So these are 3 applications for which we have published design patterns. You can get them at the link below. So we have them for Valkey, MongoDB, and PostgreSQL. This is a bit unique because you have an Azure Blob Storage to which PostgreSQL is writing backups. That is just one of the use cases of blob storage. So even though they all have their own persistent volume storage, the backup is being written over there. So in case of a complete loss, you can actually restore your environment from it. So these are some links. You can, so if you would like to learn more about Azure Container Storage, you can reach out to AKAMS Container Storage, and we have continuous updates that we share, which is available in the blog. For Azure Files, we have AKAMS Azure Files for AKS on how to use Azure Files within AKS. I'm sorry. And if you'd like to learn about BlobFuse, we have an AKAMS link for that. We appreciate your feedback. It helps us improve our services. It helps us to understand what should we offer you and how should we, and when you share your problems with us, it helps us to understand how we can help you solve those problems and challenges. So please share your feedback, send it us to at AKAMS Azure Container Storage Preview Survey. If you have any questions, you can reach out to askcontainerstorage@microsoft.com. If you have any generic questions around Azure storage, you can directly reach out to me at shsorot@microsoft.com. So with this, I think we have a break coming up, right? And I could definitely use a tea for my throat. So thank you.